Yes, sir. Sir, ready.
Okay. So the first things what is there in this chapter, that is the fundamental particle we have to study. That already you know very well. Okay. And the second one, if you are talking about,
No, sir, about this. Sir, in this chapter, I'm not having very clear conception. So, sir, it would be better if you could explain it right from the beginning.
okay, wait.
Because when this chapter was going on in the Akash classes, sir, I missed some classes due to some unavoidable reasons. So, sir, this
Uh,
chapter is not very clear with me.
okay, not a problem. We'll start from the beginning. Where your camera is not on? Camera is not on. Check your camera. No, it is not. You are not visible. Now you are visible. Now you are looking very smart. Okay. So here you see some models are there. The basic one is there, Thomson model. That is Thomson model. Okay. Next one, if you are talking about it, is going to be Bohr's model. Bohr's model. Okay. After Thomson model, it is the Bohr's model. Not the Bohr's model. Rutherford model will come. After Thomson model, it is going to be Rutherford model. Rutherford model. Rutherford model. And then we have to go Bohr's model. Bohr's model. Okay. After that, there are the after that one electronic concept. It will go. That is the next one is the electronic concept. I'm just giving you brief. That is how much we have to study because it is long chapter. And next one is electronic concept. In that one, if we talk about electronic concept, we are having the few rules are there that we have to study. The first one is electronic configuration. We have to see this one, electronic configuration. After studying this electronic configuration, we have to study the Pauli rule. This is the Pauli rule. Pauli rule. Another is
No, sir, excuse. I did not say it to you, sir.
okay. Next one is Hund's rule is there. After Pauli rule, this is going to be the Hund's rule. And then there is the quantum number. Quantum number. That is what. So it comes under this one. And quantum number also, there are 4 types of quantum number. That is principal quantum number. PQ number, principal quantum number. Azimuthal quantum number. Next one is magnetic quantum number. Okay. And last one is spin quantum number. This one. Next one, it is also coming electromagnetic wave. Here is electromagnetic wave. This is there. If you talk about electromagnetic wave, there are many things which we have to study. Okay. Like we have to study wavelength, then we have to study frequency, then we have to study the energy, these all things. Next one is dual nature of electron. Dual nature of electron. This is moving particle we have to study. Then Heisenberg principle, H-I-Z-E-N, Heisenberg.
Actually, one thing I wanted to convey to you, sir, here in our new school. So what they are doing is that they are conducting tests, like every second week, sir. We are having the chemistry test.
Okay.
So, sir, like that. So we had the test of the this chapter only yesterday only, and sir, I'm not very sure about how it went. So, sir, next week we will be having the test of periodicity. Sir,
Okay.
by then will it be completed? Then it would be very helpful. Like if that is completed, then I would be much more confident.
But it is the very big chapter. Atomic structure is very big chapter. How can we? How could? We are doing only 2 days now. We have to see the timing. It is the very big chapter. This chapter is very big. Two questions come in the NEET exam. 2 questions.
Only 2.
Oh, only 2 questions means how many marks? 8 marks.
8 marks. 8 marks.
8 marks is big marks. It is not the very small
Yes.
mark. 8 marks. 8 marks means if you are losing the 8 marks, you will be out of the 2-3 lakhs below student. 2-3 lakhs. I know. Means
Yes.
when you are ranking, when you are deciding your rank now, so even 1 marks decide, you will 1 marks put you many top. That is, it will put you the above of the lakhs and lakhs of student. So this marks is
Yes.
having very important. Okay. So these things we have to study. Now, if we talk about the discovery of electron, okay. So first of all, you should know the discovery of electron in the 9th standard we study. That is who discovered.
Yes.
This is discovered by what? J.J. Thomson. Thomson only discovered the electron. How he discovered the electron? If you you must be knowing. Okay, discovery of electron. You need this discovery of electron. You are knowing discovery of electron.
Sir, you can discuss it in short, so that will do.
Okay. What the J.J. Thomson did, he took the discharge tube like it was there. This is the glass discharge tube, and filled the gas with the very low pressure, right? He filled the gas with very low pressure. And what he did, that is both the side he placed the electrode. And electrodes are oppositely charged electrode. And these electrodes are connected with the high voltage battery. These electrodes are connected with the high voltage battery. This is the larger battery terminal is positive and smaller one is negative. So the smaller it is converted negative and here is the positive. This is called the cathode. Negatively charged electrode is called cathode and positively charged electrode is suppose it is going to be anode. What happened? Here he is taking not the small battery. He take the 2000 volt battery. Okay, this is the very big battery they were taking. So high voltage electricity they were trying to pass. And what they observed here, if you see, on passing this one, he said that is some negative charge particles are coming out from the electrode. And they are moving towards what? In the straight line towards the anode. Right. So these rays are terms to be, these rays he terms that is cathode rays. Since they are generating from the cathode electrode, that is they call that is cathode rays, right? Or one other rays he also named as that is negative rays. Now, what he did here, he taken the one rays, right? He taken the one rays. And what he was started founding that what particle these rays are made up of. So he seen that these rays is made up of, this rays is quantized. It means this rays is made up of what? Small negatively charged particle. And he said these particles are what? That is the electron. Okay, electrons are going in the straight line. So this is what the concept here. Okay. Now, some properties he discovered that is asked in the very fundamental ways. Suppose if you are placing here the field of electricity, what field of electricity you are placing? One side you are placing the positive field of electricity and one side negative.
Or that discovery and all these are important from NEET or board point of view.
No, not that much important. Not that much important.
Sir, then we can just skip this with a brief introduction and then we can go to the main portion. Sir, I think that would be better because, sir, this question from this chapter particularly, the numericals are coming from that hydrogen spectrum and like that.
Yes. So you tell me one problem. Where this rays is moved, either positive side or negative terminal. Just one question you tell me. These rays are going, which direction it should go?
Sir, from negative to positive?
Positive is here. This is positive electrode. This pole is there. This is what? Positive field of electricity. Positive field of electricity. So which direction it will go? With the positive field of electricity or the negative?
Sir, it will go this side.
Positive side. Very good. So it indicating that is they are made up of positively charged particle. Okay, yes. You tell me what is the charge on the electron? Charge on electron. Can you tell me? Charge
Sir,
on
1.6 into 10 power minus 19 coulomb, negative.
Okay, 1.6 into 10 power minus 19 coulomb. Okay, next one more question. Generally they ask, question is, what is charge to mass ratio? What is charge to mass ratio of electron? Charge to mass ratio of electron. Mass ratio of electron.
Sir, that value I don't remember right now, sir.
Mass of electron, if you're talking about mass of electron, it is something 9.1 into 10 to power minus 31 kg.
Minus 31.
In the gram, can you tell me mass of electron in the gram? It will be 9.1.
Sir, minus 31 would be minus 33.
33 or 34?
Sir,
32, 33,
34, sorry, sir,
34 gram. And charge you are already knowing, na? Charge you already know. One, you just now
yes.
do, 10 power minus 19 coulomb. You tell me charge to mass ratio in the kg per coulomb ratio.
Sir,
Can
we
you?
will have to divide both of them. So we will
Uh,
have to divide both of them. Then what we'll find, that would be the charge to mass ratio.
okay, you calculate. Here is the charge is there. Charge is there, and downside it is mass is there. Okay, calculate this one. Can you try this one?
Yes, sir.
Try it. I will tell you the answer, correct answer. Mostly
Charge
what?
by mass.
Charge by
Yeah.
mass. Yes.
By 9.1, 10 power minus 31.
9.1 into 10 power minus 31 and divided by 1.6 into 10 power minus 19. So what is there? 91 upon 16 into 10 power minus 31 plus 19. So it is going to be, if you divide these two things, it should come something one. Very good, very good, very good. Okay, it is coming, Sanoe, 1.75. The answer is 1.75. No, some answer is, I think, I don't know. Here you see the answer I am writing. Here is correct answer is 1.75 into 10 power minus 11 coulomb kg inverse. Kg inverse. See how will it come or not? Charge to mass ratio. We put the value wrongly, yaar. We put the value wrongly. Charge is numerator and mass is in denominator. Got it? Your voice is not coming. Voice. Charge is
Sir,
one.
then it will be coming like that only. Yeah. Yes,
10
sir.
power 19 and 9.1 into 10 power minus 30. So it will
Then
come
it
like.
will come nearby 1.75 only. Sir,
Okay,
one
okay.
only.
This is what the okay. Next one. So discovery of proton you can study. Discovery of neutron you can study. And Thomson model is also. Can you recall the Thomson atomic model? Thomson atomic model. Can you recall anything about that?
Sir, according to Thomson atomic model, sir, there is this type of a sphere which is composed of total positive charge.
Okay.
And sir, we are having 1 second, sir.
Okay.
This is a total positive charge, and what we are having is we will be having these negative charges like this embedded on the surface of that one positive charge. This would be the negative charges, and this is overall in spherical in shape. This would be spherical, and what at the end we will see that positive equal to negative charge.
So atom become neutral.
Neutral.
Okay. Why this model failed then?
Sir, failed because does not explain the stability of the atom.
No.
This one.
No. Stability was in the Rutherford atomic model.
Yes, sir, but in our school we were told that it could not explain the stability because if it were to be like this, then if we take a smaller section of this like this, here we will find many negative charges placed very close to each other. Then sir, this won't be possible because there would be repulsion. There would be repulsion here. Plus further we were also told that if this total thing is having the positive charges all around this one, then sir, there would be repulsion between positive charges also. So this thing cannot be all together like what it is. It cannot be together. It will definitely break away.
Okay. Okay.
And the second is, sir, it could not explain the formation of ions like that. And
So what is the problem, Sanoy? What is the problem? Here you see, you are saying that is here is the electron is there, negative charge. And just behind this one, there is the positive charge is there.
and sir, it could not explain the results of the Rutherford's experiment also.
That is the reason. Because here there is no problem. If you are saying the positive charge is on the surface, negative charge is pulling back, okay, inside. So here there is no problem at all. Okay, because it can pull
Sir,
back
this
now.
would be okay, sir. You were talking about these two, sir.
Ah.
I am talking about these two, sir. These two should be difficult to be
But
together
what is the
because
what is the problem here? They are the equal, no? They are the equal. They are the equal. So equally they can. These two you are saying that is okay. That is okay. We can consider this one. But here in the center, what are there? In the center is the nucleus is the what is there nowadays also in the center what is there? Positive charge are there. What is volume? If you talk about volume is negligible. How much? Negligible. Yes or no? Volume is
yes, sir.
negligible. But all proton, all positive charge in there in the nucleus, all positive charge. So what the reason you will give? There will be also repulsion, yes or no, in the nucleus.
Sir, then we will give the only the failure of the Rutherford model or Rutherford experiment only.
Rutherford experiment. Now you ask from your teacher that if we are giving this this region, this is small volume. If you are taking the like charges repel each other, that is okay. But what you are talking about the nucleus, there is also a small volume, right? So if it's small volume, if you talk about there are all positive charge, how is it possible? There will be repulsion. So that is also the concept of the nuclear force of attraction. One more things which
Yes, sir. Sir, this is a very valid opposition, sir. Like if they are also they are concentrating in the same point only. Might be that the electrons are away, but the protons are in the same place only. Then they should not also be like that.
And another things is there. See, even nowadays, what is the configuration? It is there 2, 8, okay, then 8, 18. So 18 are also there. Now 18 are the numbers. It is also then 32. This is number. They are present in the same orbit. But that concept is not valid. That is what that
Yes,
is not
sir.
valid. That much not valid. Okay. Now see
Yes, sir.
how they failed because they could not explain the Rutherford scattering experiment, alpha ray. Because here, if the positive charge are there, Rutherford, what he is doing, he is also passing the positive rays. This is the alpha rays, no positive rays, alpha rays. What he is observing here, he is observing that is all the rays are passing straight. Okay, it means that is the normal physics concept said that is the like charge repel, but here not happening. Only the very few charge, 1 out of 20,000 around, they are getting deflected. 1 out of 20,000. Okay, very few rays deflected, and one rays are getting returned back. So why this is happening? Because there is no positive charge on the surface of the atom. All the positive charge in the nucleus. Okay, so this was the failure region of Rutherford model. You must be knowing Rutherford model. Rutherford model. What the Rutherford model said? Any idea? Can you give me Rutherford model? Yes or no? Are you saying anything?
Yes, sir. Sir, the mic was accidentally off. Sir, Rutherford's model is like the solar system. Sir, it has, according to the Rutherford model, there's a nucleus at the center. According to this, there are fixed orbits where the electrons are moving. This is where all the positive charge is there. Sir, nucleus. 1 second, sir. The radius of the nucleus will be of order 10 to the power minus 15
Okay.
meter, and the radius of the rest of the atom should be around 10 to the power minus 10.
Okay.
Sir, this is the size difference. This occupies a very less volume of space, and here these electrons are there which are continuously revolving around.
What is the unit of this one? What you wrote the value? This unit? What unit?
Sir, this should be meter.
Okay. Thank you very much. So this is what the correct one. How this model is getting failed? Why this model failed?
The major issue for this is that it could not explain the stability of the atom. If something was to move like this, and this, sir, then it when moving, it would some of its energy would be converted into kinetic energy. So in that case, there would be continual energy loss, and there would be continuous energy loss, and this rotation should be like this, sir. It would go straight and straight and straight to the nucleus. But sir, that is not what actually happens, because if that happened, then the atom should not be existing. So,
Okay,
sir,
okay.
this is the failure of this model.
Okay, okay. So this is the everything you know very well. Now we are going for the Bohr's atomic model. Bohr's atomic model. Bohr's atomic model generally on this model, that is the question is generally they ask. Okay, generally.
Yes, sir.
Either Bohr's atomic model, what are the important point? Like calculation of radius. The first one is problem on radius, calculation of radius. One question they can ask on this one. Or that is if they are not asking radius, then they will ask the energy of orbit. Energy of orbit.
Yes, sir. Let me get it.
This will get either they will ask that is wavelength.
Wavelength energy.
Wavelength of spectrum. What is the spectral line? Wavelength of spectral line. That is also they can ask. Next one they can ask if you talk about the energy. Energy is the like that one. And another thing, the number of spectral line. Number of spectral line. Number of spectral lines. No.
Sir, and
Okay.
that series is like the Lyman series, Balmer series, Paschen series.
Yes,
They
yes,
are
yes,
also
yes.
important.
They are also important. They ask the wavelength of that series. That is lowest wavelength, highest wavelength. They were
Sir, and
low.
sir, radius of that one, sir. Radius. Yeah, yes, sir. You already mentioned that one. So radius of orbit also sometimes they ask, like if the radius of first orbit of this H plus is this, then what is the radius of another one? So this type of questions are coming.
They ask even the ratio also. So
The radius of orbit and radius of shell are the same thing, no?
yes, 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 yes. So Sanoe, the derivation you want radius of derivation radius or the you not required? What you are saying?
Sir, is it required? Sir, you say whatever you said, that is fine. I do not know.
What is the problem na? The problem is sometimes we skip in our mind the what is the formulas. Okay, so in that
Yes.
case only this derivation help. If you miss the formulas, otherwise if you don't miss, then there is no need to go. Okay, so by the way, let us try to understand. It will take 1 minute. Why
But
to this?
then, sir, you can show that derivation. At least then I can understand from where it is coming. Then in the
Okay.
dire case that I do not, remember that formula, then I can derive this.
Okay, okay, okay. See, derivation of radius of Bohr's orbit. Okay, derivation of radius of Bohr's orbit.
What I want to ask is, sir, suppose this type of formula I forget. So, sir, like is it possible to derive this during that examination or because
No.
180 questions in 180 minutes approximates to 1 minute per
No.
question.
It is not possible. It is not possible. But in case you got the very much confusion, like that today you said that I did not memorize the mass of the electron. Okay.
Yes.
But if you are getting any idea, suppose the radius is there. Here, radius I am writing the radius. So Rn is there. Okay. It is there 0.529. This value you can memorize. There is no problem. But here is the formula. In the formula, it is n square z. Okay. It will be the Angstrom. Yes. But in case you miss that one, in case what the student generally miss here, this value they can memorize, no problem. 0.529 automatically you memorize. But sometimes this get confused. So we can write they will write z by n square, Angstrom. Right. Sometime you will write that is Rn is equal to 0.529. And then you can write z square upon n square. So in this type of confusion it comes. Okay. Generally this type of confusion. So for that purpose, generally we derive to know that is what is there in the numerator and what is there in the denominator. Only that much only. That purpose is this much.
Yes, yes.
Getting now. If you are not going to forget, let it be like that.
No, sir, I may forget. Sir, you please explain.
Okay. See, what is there? It is how it is calculated. It is calculated from centripetal force. centripetal force, and centrifugal force.
Yes.
So if you talk about the one force, which is suppose electron is moving like that, whatever the considered, if it is electron. So if it is the electron is moving like that in this direction. So one thing is there, here is the positive charge are there. So these are they are pulling back. Okay. And since it is the motion, so it is going to be outside also. So this is going to be centripetal force, mv square by r is equal to, here if you write that is this force. Okay. This side, that is called the centrifugal force, or you can say that is also Coulombic force. Okay. So how we represent this Coulombic force if you are writing? So we will write that is, suppose Q1, Q2. You must be studied this one. Q1, Q2 by what is there? R square. Yes or no? And here what is the charge is there na? Here will be the Q1, Q2. What we are I am writing this one. I am writing this one the constant. Okay, charges as constant. And for hydrogen
Sir, I
atom,
think this one is the Coulomb force, na sir? F equal to
yes.
K Q1 Q2 by R square.
Yes. This is the, and here this we multiply by what is, we will multiply ZE square. ZE square also. Z is the, no, either we are writing Z is what? Z is the atomic number, and E is the charge of electron. So how we are writing this one? Let us try to write mv square by R is equal to, that is this we are converting into the K. Let it be the K. K.
Yes.
It is the ZE square upon that is what going to be R square. This is there. Okay. This is the equation number 1. Okay. We know what we know. If you are talking about the one more concept, that is the angular momentum. What is the angular momentum? Can you tell me angular momentum?
Angular momentum is, sir, m omega.
This is angular momentum of electron. It is there. mvr is equal to nh by, it is 2 pi. Okay. Angular momentum of electron is, either you say what we said, that is any orbital, Bohr's orbit, which is having the angular momentum multiple of nh by 2 pi, in which only electron can move. So this is the equation number 2, right? From 1 and 2, what we are going to do, from this one, let us try to find out the value of V. If you are find the value of V, so what it is going to be? It is going to be nh by, 2 pi mv, right? 2 pi mv.
Yes.
You don't consider to be the equation number 2. What we are going to do? We are going to
Sir, it will be mr, nh by 2 pi mr.
mr. This value we are going to place here. Okay.
Yes.
So if you are placing this value here, so what we are going to get? Okay. So let us try to put out the values here. So if I will write m, v square value, what it will be there? N square upon h square divided by, this will be the 4. Here will be, this will be the again pi square, m square, r square, equal to, this is again this side what is there? K ZE square upon R square. This is there. Okay.
Yes, sir.
Somewhere we are missing this one concept. Wait, Sanuena, wait, let me check in the book anything we are missing.
Yes, sir, I'm waiting.
Okay. If we are putting the square in the square, v square of the square. Square, that is okay. Here actually the problem is both side r square is coming. That is the problem. Here is also r is there, no? No. This is r.
Sir, r square is coming, then sir we can cancel that one.
But you cancel, then how can you calculate the radius?
Sir, we are having the problem with the radius only, sir. That is only getting cancelled.
This is
I
the
think
R.
there is some mistake, or might be we have not done it properly.
No, that is mistakes are not there. Otherwise, what we can do now, in spite of putting the value of V, you can put the value of R one side. If you are putting the value of R here, okay. Let us rearrange. It will come automatically. It come. Nothing is to worry.
Yes, sir.
It will come. Okay. What we are doing here, one R and one R we are cancel out. Right. So MV square is equal to KZE square upon what we can write, that is R. Yes or no? So R is equal to what we can write. It will be the KZE square upon MV square. MV square. And here V is equal to, just now we calculated na, NH by
But Z
2
will be the atomic number, na, here.
Z is the atomic number, yes. So here now you can plug out the value. It will be the K. Here is the ZE square, no problem at all. Here is M is as it is. If you are putting this one, so it will come the N square. Then it is going to be H square. This is the N square, H square. Total divided by what will come? 4. This is the pi square, V square, pi square, M square. And this is again going to be R square, right? Now see this one, what is going to be there? Okay, where should I write? Okay, this one. So if you are considering this R, here R is also the problem one, is the R1, where it is going. Okay, let us see. The R is equal to, it is going to be, if you are putting this one, na, so
Yes.
N is this one, N. So N will go in the numerator, N square, right? And then where is the Z? Z will come, along with the Z is also coming there. So no, the derivation I will let you know. I will let you know by
Yes,
the.
sir. Yes, sir.
Because it is,
Sir, you can do one thing, sir. You please write the derivation on the paper, on a paper, and you can send me, sir. If I have any problem in understanding that, sir, I will let you know.
Because here a little bit confusing. Suppose if I will taking this one in the numerator, Z is also a here. So where we
Yes,
will
sir.
so put? So little bit confusion. Why the confusion is coming? Okay, I'll tell you, because we somewhere we multiply and divide that one. That is why it is coming. So simple. The radius formula is what is their radius formula. This is the Rn is equal to 0.529 into
529
N square
by
upon Z. This is there. So it is coming in the Angstrom, and Angstrom you can put in the Angstrom, you can convert in the any of the unit. So suppose the question is the first question they are asking. Calculate the, what is the question? Calculate the ratio of radii of Bohr orbit of Bohr's
Sir, but
orbit.
this is applicable only for hydrogen-like atoms, na?
So there is no problem, na? No problem. Because here the electrons are not there, na? Electrons. Atomic number
Sir, then
required.
anyone we can do.
Here electron is not required. That is single electron species it is used. Single
Yes,
electron.
sir.
But in the formula there is no electron. Only it is the atomic number, right? So this
Yes,
can be
sir.
used for anything. Calculate the ratio of radii of Bohr orbit of hydrogen atom. Hydrogen atoms of first, second, and third orbit. First, second, third, and fourth orbit. Fourth orbit. Can you try this one?
Yes, sir.
Hmm.
Sir, answer would be 1:4:9:16.
So this you are knowing. Okay. So other things, what it can be the question. Achha, one more question they ask.
Yes, sir.
What is the ratio of radii of second orbit of hydrogen and suppose I am taking lithium, hydrogen and lithium 2 plus ion, hydrogen and lithium 2 plus ion. Can you tell?
Sir, it would be, sir, second orbit of hydrogen and lithium.
Yes,
This
second.
would be 4 by 4 by
Calculating.
hydrogen, lithium. Lithium would be 3, 9.
Hmm.
3, 4 by 4 by 9 means 4 by 1 into 9 by 4. So 9 is to 1.
9:1. Okay. So when the nuclear number of proton is very large, okay, 9:1, is it coming the correct or not? I don't know. RH by RLI. This is also second and this is also second. Okay. So 0.529. Here is also 0.529. Here what
So
you did
0.529, sir, why we will take? So
uh,
0.529 ratio, inevitably it will cancel.
uh,
So that
to
4
see.
also will cancel. So sir, it makes 1 by 1 by 4, 1 by 1 divided by 1 by 9. So that would make it 9 is to 1.
So this is also going to be 4 by, what will be there? 4 by 9, right now?
Yes, sir.
So 4 by 1 into 9 by 4. So that is, it is coming 9:1. Okay, correct only. There is no problem. Now the next one is there. What is their energy? Okay, energy of Bohr's orbit. Energy of Bohr's orbit. So what is the formula of energy of Bohr orbit? Energy of, do you memorize? Bohr's orbit. Yes or no? What is the energy of Bohr orbit? Where are you? Not visible. Energy of Bohr's orbit.
I said it got off, I think.
Okay, tell me.
G-
Energy of Bohr orbit in electron volt. You tell me in electron volt. What is? So E n is
So
equal
one
to.
second, sir. Can you please let me recall for 1 minute?
Okay. Please.
Sorry, my energy should be. Sir, formula RH Z square by M square.
That is the Rydberg equation you are saying. This is simple one in electron volt. What is there? Minus 13.6 into what is there? Z square by what is there? N square electron.
No, sir, I did not know this one, sir. I knew the Rydberg formula only.
No. There is the many ways to calculate. But here what we are calculating? We are calculating the energy of orbit. So orbit we have to take the orbit number and atomic number. Atomic number is the nuclear charge is pulling inward, and atomic number which orbit is there. This one. Otherwise, E is equal to what is that? Is H nu is there now, or E is equal to
Yes.
Hc by lambda. We can use this one. So where